This isn't an FAQ because most of what's been expressed have not been questions, so this is a frequently raised objections video. 1. The exam was not like Newton. That's correct, it wasn't. Newton is very good at giving you a handful of example problem types, and through repetition and practice you can get those problem types down pat. What Newton is not good at is evaluating whether you understand what you were doing rather than simply following a pat procedure. Several parts to that. First, why do you need to understand it rather than just be able to do it? If I only test you on being able to do it, I am doing you and your education a disservice. Your major, even if it's not chemistry, which it's not for most of you, requires chemistry courses for a reason. They require it because their subject matter knowledge requires you to have a background in chemistry sufficient to apply it to your major. And in that major, when you are applying your chemistry background knowledge, it will not be in the form of a Newton-style question. Even within chemistry, just being able to do it is insufficient. In Chem 111, you were taught how to identify whether a compound was covalent or ionic. In Chem 111, you were taught dimensional analysis and stoichiometry. You were taught how to identify the geometry of a molecule through VSEPR. You were taught Hess's law. Now in Chem 112, you're having to apply that knowledge to intermolecular forces, concentrations, and kinetics. You'll soon have to apply that knowledge to equilibria, entropy, spontaneity, and electrochemistry. And the Chem 111 material in those contexts will not be provided neatly in a Newton-style question. You'll have to apply the ideas to a new context. It's like in a math class. Multiplication doesn't make sense if you have memorized addition facts without understanding the idea of addition. You'll remember it longer. If you have memorized a procedure, as soon as you stop practicing that procedure, you start to lose it. If you understand the procedure, you don't have to memorize it. I've been shocked this semester at how pervasive in this class an inability to tell whether a molecule is ionic or covalent is. I've been shocked at how many students are uncomfortable with the basic idea of dimensional analysis with VSEPR. And consider this, you probably learned those skills quite well in Chem 111 through Newton, and yet are seemingly lost this semester when applying that knowledge is necessary for learning a new skill. The fact that so many of you have not retained and been able to apply your Chem 111 knowledge is the best argument against Newton tests that I can imagine. Second, does the exam I actually gave you test your understanding? Yes, it was specifically carefully designed to do that. Part of understanding is recognizing what information you need to solve a problem. Estimating the solubility of strontium borate requires some measurement of how much strontium borate is dissolved in a sample. You were given that information. Constructing a procedure to make a solution of a given concentration requires you to know how to evaluate how much solute you need in that solution. Part of understanding is explaining why a trend is what it is. Which comparisons of intermolecular forces for a pair of situations are true, and which of them actually match an observed piece of data? Which considerations among several true possibilities are the most important in a given situation? These are things I was asking on the exam. Part of understanding an idea is being able to predict how that idea might apply to a new situation. We went over in detail how to determine the unit cell side length from an atomic radius and its unit cell type. If you approach that problem from the perspective of memorizing or looking up a formula, then you can find a particular unit cell side length, but you cannot find the size of the holes within the structure, despite the fact that exactly the same principles apply, and you figure it out in exactly the same way. If you know how to convert molarity to ppm by mass, by memorizing or looking up a procedure, then you can do that one conversion. But if you understand that all you are doing in that conversion is looking at the definition of the starting point, the definition of the ending point, and using dimensional analysis, you can then do any conversion from one set of units to any other. Third, did the exam attempt to scaffold the testing of your understanding so that you could see the knowledge signposts along the path to demonstrating your understanding? Yes, let's look at a few examples. The question that tests your understanding of osmotic pressure was question 14, about the depth of seawater that would be necessary in a U-tube for its weight to counteract the osmotic pressure. But I didn't just give you that question by itself. I had you determine the concentration of each individual ion in questions 1 through 11 in the correct units, sum them to a total concentration in question 12, and then calculate the osmotic pressure itself in question 13. I gave you a roadmap to the question that really mattered, question 14. Some of you have complained that getting an earlier question wrong meant that you get the later questions wrong. This is true, and I wish I'd found a way to have the graded answer of one question depend on a formula based on answers from earlier questions. I tried extremely hard to find a way to do that, and I was unable to. So the only options were to not ask the earlier questions, which put all your eggs in the basket of the last question, an unacceptable choice. Not ask the later questions, which misses the point of the later questions, which is that they're the important ones, engaging your understanding, or to do what I did. Another example, the question that tests your understanding of the effects of intermolecular forces on boiling point was question 44, where you identify the most important reasons for one boiling point to be higher than another. Again, I didn't just give you that question I didn't just give you that question by itself. I gave you the questions that help you work out which molecules are polar and which are not, questions 39 to 43. Similarly, the important question that tests your understanding of the role of intermolecular forces in surface adhesion is question 46 about the meniscus, which I set you up to succeed at by having question 45 catalog the forces that are present, including hydrogen bonding. Another example, the question that tests your understanding of phase change behavior was question 35, where you match the heating curves to different pressures above, below, and at the triple point. And I set you up for success in that question by preceding that question with number 34, where the answer specifically makes you look very closely at where the triple point is, because it keeps asking you about above, below, or at the triple point values of temperature and pressure. Whether or not the test successfully scaffolded the testing of your understanding by giving you enough of the right kinds of signposts is a very valid question. And there's one reason, and this is one reason I very much want specific feedback from all of you about how you are interpreting the questions so that I can learn better where the gaps in your knowledge and understanding are. The point I'm trying to make is that in prioritizing testing your understanding, I am attempting to give you a clear pathway to allow you the best chance of success at doing so. And I want to be able to do even better, so please help me. Fourth, how have I been attempting to teach you understanding in addition to the procedures and facts? The content videos. The videos take you through the development of the ideas, not just how to work problems. They are constructed to give you background information and then ask you through the quiz questions or through seemingly but not rhetorical questions that I verbally ask to put that information together into a conclusion or a prediction. Because when I ask you that question, you have the information you need to answer it. And the process of answering it is precisely how you develop understanding rather than memorization. This is why I'm so frustrated that the class norm has seemed to become to watch the videos repeatedly until all of the correct answers can be written down, and then taking the video quiz again in order to input the correct answers. Because that procedure is short-circuiting precisely the learning process I'm asking you to engage in while you're watching the videos. I'm tempted to switch it up and make the quizzes single attempt only, and to not release the quiz-free versions until after the quizzes are due to force you to actually engage with the videos the way they're designed to be engaged with. Except that won't work either, so I'm not going to do it. Because students would pause at the quiz questions and then go to Google or Piazza to hunt for the answers. Or there'd be an internet glitch that would invalidate one of your one attempt. So I'm going to leave the videos as they are, but I implore you, stop focusing on getting 100% quiz grade, which, if you think about it, counts for 0.1% of your final grade. And instead, actively use the quiz questions as a way to ensure that you're focusing on grasping the steps of the argument. That's the real thing you need to be learning. So, how else have I been trying to attempt to teach you understanding in addition to procedures? Small group activities. These activities are designed specifically to give you practice thinking through an argument, to take data and analyze what it means, to take you from step 1 through step 25 in a thought process where each step along the way is part of the understanding you are constructing. When I teach physical chemistry classes, a pair of 300-level courses, the in-class time is 95% devoted to these types of group activities. I hand out a book of them at the beginning of the semester, and students sit around tables brainstorming the questions as they go. These activities are less apply your knowledge to a new context idea than here's the original development of the ideas. So the content is more like the content videos in 112, but it's quantum mechanics, so it's pretty much a new context anyway. I am there with them to guide them through the process, but through that process the students construct an understanding of the material, and it sticks with them as a result of them constructing it rather than being told it. I've been told by other professors that students coming out of these classes are extremely well prepared for the following classes that depend on the content I've been teaching them. The point is that this method, called in the educational community Process-Oriented Guided Inquiry Learning, or POGIL, works. This technique was developed over a decade ago under a grant from the National Science Foundation, so it's not an experiment at this stage, as I've heard some students call it on Piazza. There are hard scientific studies on how well it works compared to traditional lectures, and the results are absolutely stunning. If I had an option to teach 112 in the same way, I absolutely would. But I don't have POGIL activities for 112 written, and my experience is that the commercially available POGIL activities are of highly variable quality. For PChem, I've written or adapted all of the ones that I use. COVID pretty much completely eliminates the possibility of face-to-face in-class working groups. Online breakout rooms in Zoom? Maybe, but managing 30 groups simultaneously, that's 120 students per class, 4 students per group, that would be a nightmare. I have not had good experience with trying to manage breakout rooms in a class with 24 students and only 2 rooms. This was PChem lab last spring, so I didn't want to put my eggs into that basket. So the small group activities this semester are specifically my attempt to get your thinking moving in the direction of understanding in the age of COVID. Unfortunately, I've learned that many groups, instead of treating the activities as consisting of a set of steps leading you through an argument, instead divided up the questions, treating them as disconnected. So it's no wonder that students that have done this didn't learn what was intended from the process, how to think about problems and figure them out, how to make connections, how the concepts that underlie the course content can be applied to a novel situation. I've also been trying to teach you this thinking process during the in-class time. Many times in class I've emphasized, don't memorize formulas. Justify the steps of a procedure. Think about how the material applies to a new situation, and learn the relationships between concepts and pieces of information more than the pieces themselves. And in leading up to the exam, when asked how to study for the exam, I emphasized strongly these points and said, yes, for the calculations, Newton can give you good practice, but that is just the minimum. I emphasized that the next step was to go through the content videos and ensure that you understood each step in the argument, because that's what the videos are, arguments, not a collection of facts and procedures. And to go back to the group activities and study not the content of the activities, but the thought processes that proceed from the start of the activity to the end of the activity. Okay, 5th. Could I have put the exam in Newton instead of Blackboard? For one of 2 reasons. Either so the questions would be more like what you're used to, or the platform itself would be what you're used to in terms of entering answers and so on. So my earlier arguments show why I feel strongly that a Newton-style homework question is insufficient for this class. That means drawing questions from the existing Newton question pool would have been horribly insufficient for what I was trying to accomplish with this exam. Second, Newton does have the capability of adding questions that are not part of its adaptive learning framework. But as I was exploring that, I found that the choices of question types that were available to me was extremely limited as compared to the question types that the developers can use when designing the adaptive homework questions. Lots of the questions I wanted to ask simply could not be asked in Newton. So in summary, I agree. The test was not like Newton. But I warned you ahead of time that it wouldn't be. And I told you the things that it was going to emphasize. But given the frequency of times I'm getting questions in Piazza that I already answered, even called out in boldface in course announcement emails I sent through Piazza, it's clear that many people aren't reading what I'm writing. And many people also aren't coming to class either virtually or in person, and are not watching any of the class session videos. So that means that I don't have a way to talk to you. Many of you didn't even get the advice I was giving. I also specifically designed course components that teach you the things that I did emphasize. But as I discussed earlier, a large number of students have found ways to circumvent the learning goals of those course components that are, in my opinion, the most important parts. Okay, the next frequently raised objection. I failed the exam. No, you didn't. And this is going to take some explanation for you to grasp. First, the exams are not given letter grades, just like none of the course components are given a letter grade, and this is for a very specific reason. There are course components that nearly everyone is getting 100% on. On the content videos, only a handful of people don't have 100% because of the successful attempts to game the system I described earlier. The Newton Alta questions also have nearly everyone getting 100%. Participation is basically free points if you just do it. I'm not even going to be checking content except in egregious cases. You participate, you get the points. So the final grade in this course, 300 of the 1,000 points are basically going to be a full 300 points for everybody. So let's pretend that the letter grade in the course components meant something, and we'll see where that gets us. Suppose you do D- level work on the two remaining components where the grades are going to be something other than 100%, so the group activities and the exams. That would be a 60 for the group activities and a 60 on each midterm and a 120 on the final, no extra credit. That would be a course grade of 720 out of 1,000, which gives the grading scheme listed in the syllabus would be a C- for the course. So were the grades of 60 on the exams and the activities really a D-? No, because the exams and activities are the only thing that distinguishes performance between students. Because of what the final grade scale of the class is, 60s on the exam are a C-. 43s would have been a D-. But all that can be confusing, which is why I discourage viewing any of the assignments as having a letter grade at all. They are just ways you can accumulate points toward your final grade. And that is why I'm getting ready to release a course grade projection spreadsheet to help you track how you're actually doing in the class. But you may respond to this very validly. Not very many people got even 43s on the exam. Yeah, you're right. That's why I'm adjusting the final course grading scale significantly. More on that in a little bit. Secondly, you also now know much more about what these tests look like, which will help you immensely on future exams. Third, I'm going to be collecting all of the information I can get from all of you about where on this exam there were leaps of understanding required that I didn't think were leaps, but which you didn't see. That will help me better give you guidance as part of question phrasing in future exams to try to avoid those kinds of leaps. Fourth, don't forget redemption points. Your midterm exam grade can go up based on your performance on the final exam. Fourth, think about this question from a designing the exam standpoint. Is there any point in me asking a question on an exam where I fully expect that every student will get it right? If I ask that question, what information will I have learned? Nothing, because everyone's going to get it right. But on a traditional exam grading scale, I would have to ask 50% of the questions on the entire exam in a way that everyone's going to get it right, just to get grades up to the point where I can start distinguishing what people know. That's a waste of your time. It's a waste of my time. I don't see the point of doing it. That means my exams are going to be hard because I only ask questions that I think some people are going to get wrong. Because of that, because of that, I adjust the grading scale to compensate. I've taught classes before where 20% in the entire class is a D, 40% a C, 60% a B, and 80% an A. I'm not opposed to doing that for this class either, except there is the issue of the automatic 100% for some of the components. Again, I'm going to get to the changes in the grading scale in a minute. All right, frequently raised objection number 3. You aren't teaching us. Okay, it's misguided to think of teaching as lecturing. Learning is the goal, not teaching. And whatever best serves that goal is the thing to do. If lecturing is shown to be especially effective, then yes, that's what we all should do. But in study after study, it is both what students think is most effective and what is shown to work the worst when compared to other options in terms of learning. This is not my opinion. This is the result that came out of hundreds of peer-reviewed scientific studies on teaching techniques. Lecturing is the worst. So the right thing to do is to focus on learning, not on teaching. The director of Boise State University's Center for Teaching and Learning, which is the resource that teaches professors how to teach at BSU, the director of that center is herself a professor of chemistry. She memorably asked a cadre of new faculty to define the role of the instructor in a classroom. A large fraction of those new faculty gave answers along the lines of conveying the content information to the students. Her answer was quite different. The role of the instructor is to create an environment that maximizes learning. That's the goal. for you to learn as much and as well as is possible. So what do scientific studies show does maximize the learning? Active engagement by the student, construction of an understanding of the material by the student through guided questions and activities provided by the instructor. The instructor telling you something works much worse than thinking about the ideas, trying them out to see what makes sense, and then checking your work, then stepping back and asking yourself, what does it all mean? The goal then is for a professor to stop being the sage on the stage and start being the guide on the side. So in this model, what does the professor actually do that can be considered teaching? Well, the biggest aspect is constructing the series of questions and activities that will lead to an understanding of the content. This is what the Greek philosopher Socrates was famous for, as his name his name is given to the method, the Socratic method. Decades ago, I taught a face-to-face general chemistry class, which is equivalent to 111, though in a different state, essentially entirely using the Socratic method. In it, I rarely made a declarative statement of any kind, instead asking the class for answers to questions. And the students got it. This is what the POGL activities that I described earlier and the small group activities in this class are doing, guiding you through, step by step, a process of constructing an understanding. This is what the quiz questions in the content videos are doing. This is why when I'm working a problem in class, or I'm working through explaining a concept in class, I'm asking questions of the students and waiting until somebody answers. Because the thought process behind those questions is the process each of you in the class need to be going through to maximize your learning. So there's still a lot for the professor to be doing in constructing these guided inquiry experiences, which I am doing from scratch for this class. But if you're constructing the understanding yourselves, what if you do it wrong? Well, that's why I've gone to great lengths to have office hours every weekday. That is why I have the classes focus on addressing muddiest points. That is why I'm diligently monitoring and responding to questions on Piazza. I'm still your guide through the process of constructing your understanding, but you have to take advantage of me in that role for it to work. Okay, next frequently raised objection. This class takes way too much effort. So the general guidelines for a university class is that every credit hour corresponds to 4 hours per week of work. So for a 3 credit hour class like 112, that's 12 hours per week that you should be spending on the class. Note, however, that this estimate is for someone who is proficient in the prerequisite material. So that would mean coming into 112 already comfortable with the skills from 111 and the prereq math classes, and thus able to do dimensional analysis, stoichiometry, and, based on the prereqs, calculus, which I've not been expecting you to do, just as a matter of course. Those should be natural and quick for you. If you have deficiencies in those areas, 12 hours a week won't be enough. So here are some time estimates for the class. First, attending class. Let's call that 3 hours a week, since it's a 3 credit hour class, despite that we're only in class for 2 hours and 20 minutes. We'll say that you use the remaining 40 minutes per week to glance over the timestamp indices for the 2 class periods you aren't assigned to, in order to watch any clips on topics you would benefit from experiencing. Second, watching content videos and taking their quizzes. The videos themselves are generally less than half an hour total for the week. Now, it takes time to take the quiz, of course, so let's call that a full hour. And suppose you pause the videos to take good notes as you go through and maybe watch it twice, so 2 hours. What you should not do is go through it 10 times to try to improve your quiz score. Reading the textbook. The sections aren't long, and there's significant overlap in content with the content videos, though obviously presented with different emphases and from a different direction. You can definitely make it through a reading assignment in a week in 1 hour. But again, if you're taking copious notes and maybe working examples, let's call it 2. Homework. There are time estimate ranges given in the What to Expect Week X posts. These estimates are compiled by Newton itself, based on statistics of students nationwide doing these assignments. Looking at the Week 5 assignments as an example, the low-end estimate is far less than 2 hours, and the high-end estimate is less than 4.5 hours. It's likely that people on the high end of this range are the ones who came into this class with a deficiency in the prerequisite material. So I'm going to choose 3 hours as an estimate to use for this comparison to the 12 hours you should be spending each week on the course. Total, that's 9 hours per week. leaving a good 3 more for things like the small group activities, an exam in a week where we don't have small group activities, participating in Piazza, reviewing the material, anything else like that. So those of you that are spending more time than that on this class, it's much more about how effectively you are working than it is about how much you are working. If you're struggling with a concept and it is taking you hours to figure it out, but you don't submit a muddiest point on Piazza or a general question to Piazza so that you can get an answer on that platform, or coming to my office hours, then you're working hard and long, but you're not working effectively. I can often clear up for you in 10 minutes something that on your own you're struggling with for hours. I'm here as a resource, and there are lots of ways to take advantage of that. Okay. 5th frequently raised objection. There's too much going on to keep track of. There are too many moving parts in this class. I can absolutely sympathize with that concern. But here's the issue. Based on what I've already said, the most important part of this class from an educational perspective is the small group activities. So those are not going away. Content videos, because of how I'm able to craft them with the animations and carefully script them, you can concisely get through the development of an idea in 5 minutes. That would take 3 times that in a traditional lecture course. And as any of you know who have tried to look at the recordings of the synchronous class sessions, sometimes the recorded video quality is pretty crappy. This means that for any student that needs, for COVID or other reasons, to take the class without attending the scheduled sessions, that student will be at a major disadvantage with respect to the rest of the class on content that is introduced during the class instead of the videos. So the videos are staying. And the quizzes in the videos are guiding you through the thought process that is so central to learning. So those are staying. Newton homeworks. While I derided those earlier, they are very good at one thing, guiding you through a base level type of calculation. And the fact that it is adaptive, allowing you to do less in an area that you demonstrate mastery in early and more in an area that you're struggling, that's fantastic. So those are staying too. Piazza? Sure, I could cancel that, but I think the number of students that I think that a number of students are really beginning to see the benefit of Piazza. So what else do you want me to get rid of? I've kind of gone through everything there is. Okay, what are we going to do moving forward? Well, several things. And this is in 2 categories. The things that I'm going to do and the things that you're going to need to do. Things I'm going to do. I'm adjusting the grading scale for the course as a whole. I'm working out the details, and I don't want this video to be ridiculously long, so I'm going to give you the gist of what I'm going to be attempting to do. Newton the content videos and Piazza participation are nearly guaranteed 300 points for the final grade, just by putting in the effort. What those don't do is demonstrate understanding over and above regurgitating information and solving problems that are exactly like the ones you've seen before. In my book, that's at best C- work. So I'll be adjusting the final grading scale so that 300 points gets you to a C-. That means you can get zeros on all the exams and still get a C- just by putting in the work. I hope you can agree that that's extremely generous, but it guarantees a minimally passing grade for anyone that puts in the work in the traditional sense. Okay. The exams and the small group activities are where you demonstrate understanding beyond regurgitation and repetition. So your performance on those are going to determine what your grade is above that C-. I'm trusting that the mastery you demonstrate in Newton, for example, means something, and then the exams, I'm seeing how far you can take what you've demonstrated in knowing, demonstrated that you know, beyond how you demonstrated it in Newton. I'm still working out the details. I'm going to post it very soon along with the promised grade projection spreadsheet so that you can predict how well you're doing. I obviously can't give you the spreadsheet until I have that scale set. So I'm going to get that out to you ASAP. Second thing I'm going to do, I'm going to listen to each and every bit of specific feedback you can give me once you've watched the exam walkthrough video, where you can identify for me how the questions I asked and the information I provided assumed you knew something that you didn't actually know. And what I'm going to do is learn from that feedback to better craft exams in the future. The understanding where there was a leap that I didn't think was there, but you do, even once you see what the question was asking for at the end, that is what I need to know so that I can try to minimize that problem in the future. but those have to be specific comments. I need you to take a particular question and say, here is what you said I needed to do in the walkthrough video. I did not see this aspect because there was this point of unclarity, or lack of clarity, or lack of information that was given. That is the kind of thing that will help me. Okay. Next thing I will do. I will work to ensure that future exams are scaled back somewhat, but the exams are still going to have an emphasis on questions that probe your understanding, because that's what I'm trying to do with them. I'm seeing with Newton and other and participation and those sorts of things, I am seeing, have you gotten the base level of information you need? And then with the exams, I'm seeing, where do you go from that? And the last thing I have listed here, although I'm sure there are other things I'm going to be doing as well, because I hope you recognize that I am actually putting in a lot of work on this class. I'm going to continue to make myself available in my office hours, on Piazza, in the class, to help any student understand any aspect of this course. Okay, now here are the things you need to do. Try to make a mental shift away from thinking of learning as about transferring facts and procedures from my brain to yours, and toward thinking of learning as figuring out general principles that can be applied in ways that extend beyond the examples you're given. I'm teaching you how to think about chemistry, not what to think about chemistry. Second, start thinking of a 0 on an exam as a C-, not a 50 as an F. Third, stop obsessing over getting 100% on the video quizzes at the expense of trying to figure out the answers from the information. Excuse me. That sentence got away from me. On the video quizzes, spend your time trying to figure out the answers to the quiz questions the first time they come up from the information you've been given, because that process is the key aspect of the learning process you're going to be undergoing. Don't obsess over getting 100% on the quizzes and trying to retake them continually until you get them. That's not a good use of your time and energy. Next, accept that Newton is the starting point, not the end goal. Next, work efficiently by stopping the hour-long struggles with the concept and use me as a resource to get the confusion fixed quickly. I am your guide on the side. Got to call me in off the side. Come and say, I am confused. Next, come to or log into class if you can and watch videos if you cannot. I agree that the feedback with me is important, but lecturing is not. Lecturing is a poor use of time because it is a script that I read, getting minimal feedback from you. That can be videoed and watched. What is more effective is to spend the time in class actually having dialogue. So also, when I ask questions in class, try to answer. Don't be afraid of answering wrong. Try to answer. Say what you think the answer might be. Finally, and this is just to try to help things go smoothly, when you get an email notification from Piazza that is an announcement from me, read it from beginning to end. There's important information in there. There's a lot of information about the exam that was sent out by these posts that I set as announcements that were sent to you by email. That would have been really valuable for you to have. And based on a lot of the things that I'm seeing, a lot of people never read that information. I have to have a way to get information to you. And that means you have to be open to listening to that information or reading that information. So I absolutely understand that this exam was a demoralizing experience. Part of that was that that I went a little too far in the exam on asking in-depth understanding questions. But those in-depth understanding questions are still the important part of the class as a whole. And And so it's got to be the focus of what you are trying to learn and what you're putting your effort into learning. And when you get out of this class, whatever it was that made you take the class in the first place, for your major, for a future chemistry class, whatever it may be, what that means is that you'll be able to take the understanding that you've gotten here and apply it rather than forgetting how to calculate a concentration, which, that's something you can look up if you need to. But if you understand what it means to dilute something, then that is a useful piece of information. That's a useful piece of understanding to have. So, the grading scale update is going to be coming out very soon. Use me as a resource, and thank you for listening to this.